Hello, welcome to the video. In this lesson, we're going to be looking at section 6.3, where we're going to look at medians and altitudes of triangles. So when uh, we have medians of triangles, so we'll look at medians first. We look at medians first. We are trying to find the center of the triangle. Basically, the median of a triangle is kind of where it gets its balance from. And in order to find a median of a triangle, we are going to find what is called the centroid of the triangle. How you find the centroid is simply this. You need to discover where the midpoints are for each line segment of the triangle. So you notice that AD is the same as DB, BE is the same as EC, and AF is the same as FC. So those establish that D, E, and F are midpoints. They all meet at the same spot, which in this case is point P. Point P is the centroid of this particular triangle. Now, when we are looking at a centroid for a triangle, we know a couple things. One, that the distance of from the vertices to the centroid, so like AP for instance, is going to be equal to 2/3 the distance of the entire line segment, like an AE. So whatever value AP is, it's 2/3 the distance of the entire line segment from vertice to midpoint. All right, and that works for all three line segments that lead to the centroid. So with that being said, here they're telling you that point Q is the centroid. Then they're telling you that SQ in this instance is 8. They want you to find QW and SW. So here S is to the vertices, so SQ, in looking at it in the formula sense, we could say that SQ will be equal to 2/3 times the entire line segment from vertice to midpoint, which is, in this case, SW. Well, we know what SQ is. We know SQ is 8. So 8 is going to be equal to 2/3 times it by SW. So to find SW, I just got to multiply 3/2 to both sides, which means that SW is going to be equal to 12. Now to find QW right here, now that I know this entire thing here is 12, I just subtract 12 by 8, which is 4. So now I know that 4 is QW. All right, from here it says they want you to find the centroid of triangle RST with these vertices. So let's see if I can get let's get a graph here. Oh, thought I had it. There we go. So let's plot these points. So I got 2, 1, which is right here. That's R. And then we got S. So let's put R. So we got S is 5, 8, 1, 2, 3, 4, 5, 8. And then T is 8, 3. All right, so what I'll do is I'll just put this on the straight edge to make it look presentable. So from here, what we have is I'm also going to write the coordinates in. So this is 2 comma 1. This is 8 comma 3. And this is 5 comma 8. So what we're going to do first, in order to find the centroid, we got to find the midpoint. So I need to find the midpoint between like RS, ST, and RT. So midpoint of RS is going to be equal to, looks like 2 plus 5 divided by 2. So that's going to be what? 7 halves. So 7 halves is about 3.5. So we got 3.5 for X. Looking at our Y values is going to be what? A plus 1 is 9. 9 divided by 2 is about 4.5. So 3.5, 1, 2, 3.5, and I'm gonna say 1, 2, 3, 4, 4.5. So right about there. So the red dot is the midpoint. So now let's look at the midpoint of ST. So ST, we add up 5 plus 8, divide that by 2, we get 6.5. Our Y values are 8 plus 3, 11, divide that by 2, 5, 5.5. So 6.5, 5. So I go 1, 2, 3, 4, 5, 6.5, and then 1, 2, 3, 4, 5.5. So it's like right about there. Then I gotta find RT. So the midpoint of RT is gonna be equal to 2 plus 8 is 10. 10 divided by 2 is 5. And then 1 plus 3 is 4. 4 divided by 2 is 2. So now I go over here. So I got 1, 2, 3, 4, 5, 2. So here's my midpoints. So those three red dots are my midpoints. And then I'm just going to go here and I'll just kind of change the color. So I'm going to go from this, the opposite vertex to that midpoint, opposite vertex to that midpoint, opposite vertex to that midpoint. And it all seems to point at this point right here, which is at what? 1, 2, 3, 4, 5, 5 comma 1, 2, 3, 4. So 5 comma 4 is your centroid. The other portion of this lesson talks about altitudes. So definition of altitude is it is a line segment or a line that is 90 degrees from a point, and in this case is an opposite vertex of the triangle, and it is perpendicular to the opposite line segment. So if you notice, you're like point A, this line that is 90 degrees from that, in this case it's CB. And we have two other altitudes. So like if we looked at C, we have a 90 degree from there, and then we got B, we got a 90 degree from there. All three altitudes meet at one point. Point G is called the orthocenter of the triangle. All right. When we are looking for an orthocenter of a triangle, a lot of it determines on what kind of a triangle it is with respect to its angle measures. If we are looking at an acute triangle, our orthocenter is going to be placed inside the triangle. If we are looking at a right triangle, in this case, our orthocenter is going to be placed at the vertex with respect to the right triangle. And if we have an obtuse triangle, our orthocenter will be on the outside of our triangle. Okay. So kind of similar characteristics when we talked about the circumcenter, but in different spots per se. So the final thing they are asking us to do is they want us to find the orthocenter with these vertices. So again, let's get our coordinate plane here. Whoops. And let's plot these points. So I have -5, comma -1, -1, -2, -3, -4, -5, -1, which is right there. And that's what, x. And then I got -2, 4. 1, 2, 3, 4. That's y. And then I got z, which is 1, 2, 3, -1. And z is right there. So again, I'll use my straight edge to help us make this triangle. And I will say that having a straight edge for these different exercises will be very important um, in order to discover what these are. All right. So from here, the easiest altitude to find will come from the vertice with y, because x, y is a horizontal line, so this altitude is going to be vertical. So it's going to be like right there. Now, the next thing we have to do is I'm just going to choose the one of the other line segments, either x, y, or y, z. All right. Eventually, we'll be able to determine that the other one will meet at some point. But what we got to do is, because it's looking at um, a coordinate plane and we need something that is perpendicular, what I'm going to do is we have to look at perpendicular slope. So let's say if I found the slope of, let's say, xy. Okay, the slope of xy equals what? So it goes up 1, 2, 3, 4, 5, and then to the right 1, 2, 3. So 5 comma 3 is my slope. So my perpendicular slope for xy would be a -3/5. Flip the fraction, change the sign, opposite reciprocals. So what I'm going to do here is go from this point here, and I'm going to find the opposite reciprocals. But instead of going down 3 to the right 5, I'm going to go up 3, 1, 2, 3, to the left 5. So we go 1, 2, 3, 4, 5. And then let's see if I go. No, my apologies, I did that wrong. So because I looked at this the slope of here, I have to use it with respect to z. Excuse me. So yeah, so this one goes up 3, 1, 2, 3, to the left 5, 1, 2, 3, 4, 5. And then 1, 2, 3, 1, 2, 3, 4, 5. So here is going to be my straight edge here. Whoops. And that green dot actually helps us out because this is where the centroid is. And the centroid is going to be at location, what, -1, -2, comma, 1, 2. So -2, comma 2 is in fact our centroid. And that is being able to look at medians and altitudes of triangles. I hope this helps. Until next time.